Hello, and welcome to York Universe, the astronomy and astrophysics podcast written by the friends, students, faculty, and alumni of York University. You will find us wherever podcasts are distributed. I'm Paul Mackin, one of your hosts this evening, and Professor Mary Helen Armour joins me. We are broadcasting live from the Allan Carswell Observatory, located at the Keele campus of York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal Time at York U Observatory. We also run in concert with our online public viewing feed, or as we call it, the OPV, which is operated by the observatory staff. We have the domes open tonight, and we will be showing perhaps some live images. And of course, we have some great archival images, which will be up there as well. To navigate to our live show and to learn more about us, please visit our website, yorku.ca/science/observatory, and follow the link to our online public viewing chat on YouTube. If you have any questions or comments about past shows or suggestions for future topics, please send us an email at observe@yorku.ca. You can also always connect with us on Instagram with the handle at YorkU Observatory, or on Facebook at Allan I Carswell Ob. All of our programs are free, but we would certainly appreciate any donations you may care to make. Please also visit our website at yorku.ca/science observatory. We will be monitoring the YouTube chat for questions and post content. Our theme tonight is Women in Astronomy, Rubin and Mitchell. But before we get to that, looking out my window right now, I can see mostly clear skies, and there's a crescent moon coming in over the western horizon, which is directly out that same said window. Perhaps we will get a look at that during the OPV. Mars, although lows in the west, is dim, but also visible tonight. How about you, Professor? How are the skies up where you are?
Not too bad. The sun is just setting. We have quite a pinkish sunset up here, so I don't know if we've still got some smog from wildfires around. I know Montreal was really bad over the weekend for air quality, so that always impacts our viewing. Although right now it doesn't look too bad, a little bit hazy in spots, but not that dark yet, unfortunately.
No, it's not. But have you noticed just in the last week, I'm I'm becoming aware that it's starting to get dark just a little bit earlier now. We're, a month past the solstice, and it's yeah, it starts to accelerate. We've got another 2 months of summer, and that's great. But so we'll get more observing in. That's a good thing. But yeah, you sort of miss the long days when they're gone.
Uh, I don't know. I kind of like it when I can go in my backyard at 7 o'clock in the evening and see some really bright constellations.
True, but when you can really do that, you're freezing. Um,
I'd prefer the cold weather after this couple of weeks. I don't mind cold weather at all.
well, I lived in the Canadian Arctic for off and on for a number of years, and though I can do really cold weather, uh, mm, I got to admit it gets old pretty fast up there. Um, anyway, this week in astronomy, perhaps you could kick us off with some news out of NASA, some news from NASA a few years ago.
Yeah, so around this time back in 2006, of course, this was the point at which the Cassini mission was very active over Saturn. Most people, if you follow astronomy news at all and you remember back that far, of course, this was when the Huygens probe landed. But on July 27th, 2006, there was another really big announcement. A few days earlier, the Cassini probe had done one of its closest flybys of Titan, only about 950 kilometers above the surface. And one of the things they confirmed with this flyby, it's something that had been suspected for some time, but they actually confirmed the presence of hydrocarbons lakes in Titan's northern polar region. So what this means is if you look at Titan, there are actually lakes of methane and ethane. It's so cold on the surface that these two that are gas in Earth's atmosphere are actually a liquid in Titan's atmosphere. And they confirmed that they actually were lakes of this material up there. And not just small lakes. Some of these lakes were up to sort of the size of some of the Great Lakes here on Earth. So quite significant bodies of liquid. And at the time, this was really an important discovery because this is the first time anywhere else in our solar system we had found liquid on the surface of another body. Right? So in looking down through Titan's thick atmosphere, we couldn't look through it except with radio telescopes, which didn't really give us enough detail from Earth-based observations. But from this close-up flyby, the instruments that Cassini had could confirm that there actually were literally lakes on the surface. And when you think about it, this is the only other place in the solar system where we find liquid bodies. It's not water, it's methane and ethane, but it's still a liquid on the surface. And what this also sort of ends up implying, and when they looked at other, combine the observations with Huygens and other things, Titan actually has a liquid cycle, very similar to Earth. So you get lakes, you get evaporation, you get clouds, you seem to have precipitation. So this was sort of, like one of those key elements in sort of looking at exactly the nature of Titan and how Earth-like in some ways is much, much colder. So it's not the same materials, but it's the same sort of liquid cycle. I don't want to call it hydrological cycle because it's not water, but it is a liquid cycle that very much mimics Earth, except using a different liquid at the surface. So, this was kind of a major discovery. This was very big at the time. Now, this is getting close to 2 decades ago, and we've done a lot of further research since. But even to this day, this is still the only other body in the solar system that we've actually found liquid on the surface. So I've always been sort of fascinated by Titan because of its, in some ways, very Earth-like characteristics. So
Yeah, yeah, it's kind of amazing. Of course, I remember the Huygens probe landing, and when it landed, it was a fair bit hotter than the surface. So there was probably, it probably melted some of the surface. But liquid like ice, water ice is on the planet, but it's so cold, it's hard as rock. So absolutely correct. There is no hydrological cycle here, but there is a liquid cycle with all the phases implied therein. And if memory serves, the lakes are all uh, set in one of the hemispheres. I think off the top of my head, it's the northern hemisphere, but I'm not sure of that.
yeah, most of
Um,
them do seem to be in the northern hemisphere, but part of that may also be a bit of an observational issue, just
it may
because of
well
the
be.
coverage from the flybys and stuff. So some of that I always take with a bit of a grain of salt.
Yeah.
So
Well, I don't think they're salt methane lakes, but you never know. There'll be some interesting chemicals dissolved in there because alcohols, and are good solvents as well. So I think that would those would probably have some dissolved minerals in there as well. But fascinating. And Saturn's got to be the planet we got to go back to. Like we're pretty good at going to Jupiter. We go to Jupiter pretty regularly. Jupiter's not really that far. Saturn is twice as far away. I mean, Jupiter's far. It's 750, 800 million kilometers, but Saturn is almost exactly twice as far. It's difficult to get to, and it's difficult to get into orbit around, but it's got 194 moons or something. Again, I'm doing the number off the top of my head.
It changes all the time, so you can't
Yeah,
keep
it
up.
does. It's going up all the time. Every time we look at it, there's more moons. And one of them actually does have what appears to be liquid water and geysers. So, it is a fascinating place. And one of the very first pictures that mission took was as the Cassini spacecraft came into the Saturnian system, it managed to get a picture of Phoebe. And sometime we should talk about that as a moon because it goes in the opposite direction of all the other moons. It's clearly a captured asteroid or centaur object. So Saturn, we could do an entire 5 shows on Saturn and not be boring at all. Um, but going back further to 1818, um, Maria Mitchell was born. Now, Maria Mitchell was an astronomer, a librarian, a naturalist, and an educator. She was born in Nantucket, Massachusetts, and that's kind of an interesting location for reasons I'll get into in a moment. Her mother was Linda Coleman Mitchell, and she was a library worker. And again, you'll notice this is quite a long time ago, but there's definitely an academic bent here. Her father was William Mitchell. He was a school teacher and an amateur astronomer, and she was the third of 10 children. And the family were Quakers. And Quakers are really interesting because my daughter actually goes to a Quaker school, Quaker-run school, and they've got an incredible focus on education and learning. And this family absolutely screams that out. But that is part of their ethical basis is that we should strive to understand the world around it and respect the world around it. And this family absolutely instilled that in their daughter. So William taught all his children about astronomy and nature. Their mother's work in 2 libraries gave them access to books. Maria showed interest and talent in astronomy and math. Her dad taught her to use many instruments, probably sextants and telescopes and whatnot. And she assisted him in his observations of the night sky. And when she was 12, she assisted in calculating the exact moment of a solar eclipse. And because Nantucket was a whaling port, women were independent. In addition to the ethos of the Quaker faith, they were independent because men could leave for many months at a time. So she opened a school in 1835 where she developed some experimental teaching methods she would later use at Vassar College. She allowed non-white students to attend her school, and of course, Massachusetts was a free state, but that would not have been common even there. In 1836, she became the first librarian of the Nantucket Athenaeum. I don't know how to pronounce that, but she would work there for the next 20 years. The limited operating allows her to continue to work on it with her father on astronomical observations and geological calculations for the U.S. Coast Survey and to continue her own education. So in 1847, she discovered a comet on October 1st, 1847. 1847 VI, I love comet names, 1847 VI C/1847 T1, and she discovered it at 10:50 in the evening on October 1st, 1847, and it was known as Miss Mitchell's Comet. He was presented with a gold medal for the discovery by King Christian VIII of Denmark about a year later, October 6, 1848. The prize had been established by King Frederick VI of Denmark to honor the first discoverer of each new telescopic comet. She was the first American to win the medal and the first woman to get an award in astronomy, although Carolyn Herschel did get an award, I think, posthumously, somewhat before that, but this is certainly the first live person. The discovery brought her fame, and she entertained many academics at her home, including Ralph Waldo Emerson, Herman Melville, Frederick Douglass, and Sojourner Truth. And again, this screams Massachusetts. This screams sort of the New England uh, intellectual crowd. Mitchell took up a position in computing and field research for the U.S. Coastal Survey in 1849. The position including tracking the movements of planets and compiling tables of their positions to help in animation. She joined the American Association for the Advancement of Science in 1850. I mean, this just goes on and on. In 1865, Mitchell was appointed a professor of astronomy at Vassar College by its founder, Matthew Vassar, becoming the first female professor of astronomy. She was also the director of the Vassar College Observatory and edited the astronomical column for Scientific American. She became the first woman elected to the American Philosophical Society, alongside with Mary Somerville and Elizabeth Cabot Agzins in
Magazines.
1860. Agazines. Okay, I'm terrible with pronouncing names. In 1869, in her classes, Mitchell reported neither grades nor absences and advocated for small classes and individualized attention and incorporated technology and mathematics into her lessons. Her students' careers were limited by their sex, but she emphasized the importance of their studies. Thus, I cannot expect to make astronomers, but I do expect that you will invigorate your minds by the effort at healthy modes of thinking. When we are chafed and fettered by small cares, a look at the stars will show us our littleness, show us the littleness of our own interests. And that's great. I mean, I personally, if I'm feeling a little under the weather emotionally, an evening out under the stars will always lift you and help you recognize how important the concerns you have are compared to the vastness and glory of the universe. Her research interests were varied. Planets like Jupiter and Saturn, their moons, nebula, double stars, and solar eclipses, all interested in her. She and her students began photographing sunspots, relatively new. Photography was relatively new around then. In 1873, when she discovered that she was being paid less than a younger male colleagues, she and Alida Avery and other members of the faculty demanded and got salary increases. She taught at Vassar until she was 70 in 1888. Mitchell attended the Anti-Slavery Convention in Nantucket in 1841, which was 24 years before the Civil War began. Frederick Douglass made his first speech, and she participated in the boycott of Southern cotton. She advocated for women's suffrage and education, and again, that didn't come for another 80 years, helping to found the Association for the Advancement of Women. She was the first woman elected a fellow of the American Academy of Arts and Science and the American Association for the Advancement of Science. She died at the age of 70, 1 year after she finished teaching, on June 28, 1889. Maria Mitchell Association, the Maria Mitchell Observatory, and the Maria Mitchell Aquarium are all named after her. And reading that bio, man, don't compare yourself, because this was a rock star.
Yeah, she was quite an impressive figure for her time, because it's like I said, many women in astronomy at that time simply did not get credit for their work. Like a lot of the credit we give to to female astronomers, whether it be Henrietta Leavitt or Vera Rubin or Annie Jump Cannon, didn't actually happen until more recent decades, because it was mostly their male supervisors that end up taking the credit. So she was, I guess, one of the early ones that actually was recognized by many of these associations. Now, teaching at Vassar, which was a women's college, probably was an advantage for her. But yeah, quite an active person in her various pursuits. My next little blurb actually talks a bit about is related to some of the work she did too. On July 29th, 1878, there was an eclipse that occurred over the US. And Maria Mitchell was actually one of the people who went to observe it, because what happened is this was one of the first times that they could actually observe an eclipse from height. They went into places at Colorado, where they could be sort of up a little higher, typical to where many observatories are built now. And from here, they could observe the solar corona quite a bit. They also were looking to see if they could detect UV light. But one of the very interesting things they were all looking for at the time was actually a potential planet that they thought might be inside the orbit of Mercury called Vulcan. Now, this sort of search for Vulcan was interesting because, of course, from the time back to, not long after Isaac Newton, when he worked out sort of the laws of gravity, when they worked out the details of Mercury's orbit, there was a problem. It didn't There was a deviation relative to what they thought it should be based on Isaac Newton's laws. So one of the things they were looking for in this eclipse, because of course it blocks out the sun, and then if there was another small planet close to the sun, maybe potentially they could see it. Now, obviously they didn't, because Vulcan doesn't exist. But it was during other eclipses later on that they managed to make some other observations, and Mercury's orbit was eventually explained by a fellow by the name of Einstein when he worked out general relativity, because Mercury is actually so close to the sun that the sun's gravity warps space measurably, which is why Mercury's orbit has this funny kind of, I won't quite call it a wobble to it, but it forms a bit of a funny rosette that's due to general relativistic effects. But it was this eclipse when they were still looking at it. And there were quite a number of names there. Other people who were there were Asaph Hall. If you sort of know anything about the history of astronomy, he was the one who actually discovered the moons of Mars, and he had discovered them not long before this observation happened. So this was a couple of high latitude areas in the Rockies, and there were some pretty, like big names at the time who were involved in this effort. And people had been observing eclipses before, but I think this one was really one of the ones we first had a big group of scientists who got together and made these detailed observations and looked at the corona and looked at some of these other effects. And from here on in, this tended to happen a lot more. I mean, even, current eclipses, you always have all kinds of people who travel to where you're going to be in the path of totality to try and make these observations to this day. Now, they didn't take photographic records at that time, but if you look around and you sort of Google eclipse of 1878, there are a lot of the really good diagrams they took that showed sort of what to them during this about 3-minute eclipse, what they could see of the solar corona and that. So it was really, I think, the start of really serious observing of the sun during an eclipse and looking for some of these things that prior to that they were observing eclipses. But this is where it really turned to a bit of a different studying the sun and studying its characteristics during an eclipse that you couldn't do any other way. Nowadays, we can use spacecraft and we can create sort of an artificial eclipse and block it out and photograph the corona and all that. But in that day, you couldn't do it. So this was a pretty big moment to be able to sort of see that more directly in a way that you couldn't when it wasn't during an eclipse. So it was kind of an interesting event. And it was, again, something that Maria Mitchell was involved with at the time.
That's amazing. You mentioned Hall, who discovered the moons of Mars. There's an interesting story also related to woman in science that's kind of fun because Hall discovered the moons of Mars, Phobos and Deimos, and he discovered them in just a couple of nights. Now they're very, very small. We didn't know a lot about them. So eventually, of course, they were imaged by spacecraft, as you mentioned. And they were trying to figure, they saw some craters on them, and there was one prominent crater, and they were trying to figure out a name for it. And someone asked them, one scientist, planetary scientist working on this said, well, does anyone know what Hall's wife's name was? And it was Angeline Stickney. And so that crater was named after her. But she was also a mathematician and a suffragette, and quite an amazing woman in her own right. And so, and she was also involved in the astronomy of her husband. And she actually encouraged him to look for the satellites of Mars when he was ready to give up. And he had already discovered, and he successfully discovered Phobos and and Deimos. But she also demanded equal pay for the work she did. She was refused, and then she just discontinued her work because she was helping calculate the orbital periods of the satellites. So, really interesting person, and. But it shows you that there was, and this all ties with the suffragette movement, which changed things in the 1920s in the U.S. It was a fair bit earlier in Canada, but uh, way too late in Canada, but earlier than the U.S. Um, so on to another real powerhouse astronomer and much more current, born on July 23rd, 1928, Vera Rubin. That's her birthday. She was born Vera Florence Cooper in Philadelphia, Pennsylvania. She was the younger of two sisters. The family was Jewish and had roots in Eastern Europe. Her father was her father was an immigrant from what is now Vilnius, Lithuania, but then it was part of the Russian Empire. And he anglicized his name from Pisach Povareski to Pete Cooper. He was an electrical engineer and worked for Bell Telephone. Her mother was Rose Applebaum, whose family had immigrated from present-day Moldova and Ukraine, and they met at work. Family moved to Washington, D.C. when Vera was 10, and she became interested in astronomy, building a telescope out of cardboard with her dad and started to observe and track meteors. And this was not an unusual thing. Until even the 1980s, people would often build telescopes out of couple of mirrors and whatever their rigid material they could find to mount them. And there was many amateur telescope makers out there. I was one myself in the 1970s. But so she graduated from high school in 1944, and ignoring the advice of her teacher to become an artist, she decided to go to Vassar College, which is the same where Mitchell taught, to study science. She earned a degree in astronomy in 1948, and she was the only graduate in astronomy that year. She tried to enroll in Princeton for graduate studies, but was denied because they didn't allow women to study astronomy there until 1975. When I read that, I was shaking my head. I'm still shaking my head. Um, she was accepted into Harvard, good for her, but instead chose to go to Cornell, which is a great school. And as she was engaged, and that's where her finance, Robert Joshua Rubin, was doing graduate studies in physics. The Cornell Astronomy Department was very small, only 4 members, but it had an excellent physics department, and she could work with physicists like her husband. And Morrison, and Philip Morrison, Hans Bethe, and the legendary Richard Feynman during her studies. She worked with astronomer Martha Carpenter on galactic dynamics, and this is where things start to get interesting, and studied the motions of galaxies, making one of the first observations of deviations from Hubble flow. Her research provided the existence of provided early evidence of the existence of the supergalactic plane. She gave birth to her first child in 1950, and she would have 4 children with Robert, all of whom went to STEM fields. She earned her master's degree in 1951. She ended up getting her PhD from Georgetown University, and none of these schools are fly-by-night organizations. I mean, we're talking Princeton turned her down. We're talking Cornell, Harvard, and Georgetown, all Ivy League, where her dissertation concluded that galaxies clump together rather than being randomly distributed. And hold that thought. She was an instructor of math and physics at Montgomery College for the next year. And then from 1955 to 1965 was a research associate in astronomy, then a lecturer, then an assistant professor of astronomy. She began a collaboration with Jeffrey and Margaret Burbridge in 1963, where she made, and this is where it gets interesting, the first observations of the rotation of galaxies. She joined the Carnegie Institution in 1965 in the Department of Terrestrial Magnetism, returning to her work-related thesis in collaboration with Kent Ford and culminating in the discovery of the Rubin-Ford effect, published in 1976. The Rubin-Ford effect is an apparent anisotropy in the expansion of the universe on the scale of 100 million light years. It was originally dismissed by leading astronomers, proved to be valid, and is now known as large-scale streaming. She briefly studied quasars before moving on to rotational curves of galaxies. She observed flat curves. The outermost material of the galaxy was moving as quickly as the center, and that makes no sense. She observed the differences in the predicted and observed angular momentum in galaxies based on visible light. She showed that at the speeds they rotate, the gravity of galaxies was due to their visible component, the gravity of galaxies that you could measure from their visible components was such that they should fly apart. So there must be an invisible mass keeping them together. Okay, and masses are, uh, caused by matter, and invisible means they're dark. She basically put together the basis for the discovery of dark matter. She became the first female astronomer to observe at the Palomar Observatory. She was initiated as a faculty member at the Vatican Observatory Summer School. She retired from the Carnegie Institute in 2014 as a senior fellow of astronomy. This work has been widely accepted as evidence for dark matter. Her work showed there must be 10 to 15 times more mass as could be directly observed in observatories. She also observed that some material in galaxies was rotating in the opposite direction of the galaxy, challenging the idea that all material in the universe was moving in the same direction. Um, this was also the first evidence for galaxy mergers. She was a lifelong advocate for women in science and mentoring female astronomers. She received many honors, including the Bruce Medal, the Gold Medal of the Royal Astronomical Society, the National Medal of Science. Our favorite observatory, the Vera C. Rubin Observatory in Chile, is named after her. Robert died in 2008. They were married for about 60 years, and Vera outlived him by 8 years. And she died in 2016 at the age of 88 of natural causes. And a great quote from her: "Don't let anyone keep you down for silly reasons such as who you are, and don't worry about prizes and fame. The real prize is finding something new out there."
She was quite a spectacular character in astronomy, and it's like I said, even though you've gotten past voting rights for women and everything, you can still see the kind of biases she had to work against. I mean, it's not it's like kind of frightening that in some ways within, current lifespans there were uh Ivy Leagues like Princeton who simply wouldn't admit women to a lot of programs. I mean, this is like 1970s, like seriously.
1975,
I know.
my jaw dropped
I
open
know.
when I
I
read
didn't
that.
realize it was quite so late for them, but even in the 1940s and 50s, it was difficult for women to get into many, many schools. I mean, it was, but it's like I said, it's people like her who inspired whole generations. It became sort of I don't know, the mentor, or what, not even mentor, but sort of, I guess, role model for so many other women who followed them. So,
Oh, and men. I mean, this was
yeah.
she was epic. And the telescope is absolutely, I mean, one of the missions of Vera C. Rubin Observatory is looking for dark matter, but so aptly named in her honor. Just a rock, just a rock star, or I could say the ultimate rocket scientist. I mean, she really was that impressive. Um, I'll just take a quick side note here that if you take a look at the OPV right now, we were just looking at Deneb, and we're moving on to M11, which is the wild duck cluster. We should be seeing that there in a moment. But you can see our live observing with our star field and the actual observed images from the telescope live. And it's now time. We're halfway through our time tonight. So just a reminder, you're listening to York Universe. We are broadcasting live from the Allan Carswell Observatory at York University in Toronto, Ontario, Canada. Please look at our website at yorku.ca/science/observatory to join the chat. If you have any questions or want to see some of our content, tonight, you are listening to Professor Mary Helen Armour and me, Paul Matkin, and we have been discussing some historical items. If you're interested in our online public viewing, and I would absolutely encourage you to do this, please navigate to our website and follow the links to join in that fun. And tonight, it's a good night. M11 is one of my favorites. We also do have a couple of reminders before we get into our news items for this week. As with most weeks, we're doing something at the observatory for the public. This week, we'll be hosting an observatory tour in the Petrie building at Keele campus this Wednesday. Tickets are free, and a link can be found on the website to get to them. And of course, donations are always welcome. On alternative weeks, so that would be next week, I guess the 6th of
Yeah, this summer,
August.
this summer, it's actually been a little messed up because of some big tour groups we had. So it's
Yeah.
yeah, we end up with more Arboretum days in sort of August than we did in July.
So we do have the Arboretum nights coming up,
Yeah.
and basically they're fun. You go to the fifth floor of the York University Arboretum parking garage on the Keele campus, and you go up to the fifth floor. You can take an elevator, you can take the stairs, and we have a bunch of telescopes up there, and you can look through them live, and it's great. And things kick off around 9 p.m. starting in August. And July 30th. So let's get into some items in the news. Mary, you've got
Yeah.
a quizzical question. When I read this one, I sort of laughed because I sort of knew where it was going.
Yeah, and it always comes up, and I think, like we have to touch on the topic because if you kind of ignore it, it can breed in the background in some unpleasant ways. But um of course, most people, if you're following astronomy news, and we've talked about it on the podcast in last week as well, they were talking about 31 Atlas, which is a cometary type body that has now entered our solar system and is tracking through. And in this last week or so, we had someone who posted into a preprint server, which means this is sort of a draft of their paper. It hasn't been reviewed. It's just sort of, okay, I'm putting it out there because this is what I found. Put up on a preprint server an article that speculates that 31 Atlas could actually be an extraterrestrial space probe. Now, this came up too when the first one, Umeo came through the solar system. Is this an alien craft? I don't know if you've read them, but of course, Arthur C. Clarke Rendezvous with Rama sprang to mind.
Rendezvous.
Yeah,
This is all descended from Rendezvous with Rama,
yeah,
which
I know.
apparently is going to be made into a film. That's very exciting, but it
Yeah,
is fiction.
but it is fiction. So this sprang out. And various kind of speculations, but this is a preprint, so there's really not necessarily any potential, like uh a lot of experts are calling it nonsense, but I think you have to address it because when somebody throws it out there, you have to, I think, touch on it. So the question I think that some people have is, could you actually tell if it was a spacecraft or not? And certainly, while it is in the solar system, yes, we could. There are aspects of its orbit that could give us a sense if it is natural or artificial. If we take spectra of the surface, if as it moves, into the solar system, It's going to get quite close to some of, I think it's Venus and Mars. It will pass fairly close to. And as it passes into the inner solar system, if it shows any characteristics of being a comet, where it develops a coma, where it develops a tail, these would all tell us it's a natural object. Um, I think the chances of it being artificial are pretty small. This one is quite large. We're talking kilometers in size. So this would have to be a very, very, very large spacecraft. And if this is supposed to be like an unmanned ship of some kind, this seems like excessively large to bother with, to just for that purpose. So most experts think this is kind of nonsensical. But there are ways we can tell, right? As we observe it, there are aspects of its orbit and its composition and its behavior that will tell us if it is natural or artificial. In all probability, it is just a natural object. But it's not necessarily wrong to speculate, right? I mean, you throw those ideas out there to see if you can, prove it or disprove it. Uh, but it's like I said, I think it really annoys experts when someone flips something like this up on a preprint server where it gets all kinds of attention, and yet there's really very little behind it, right? This is someone, taking advantage of a preprint server, I think, to get a bit of cheap publicity out that. Um,
Yeah, yeah. I mean, extraordinary claims require extraordinary evidence, and it is really big. I think it's 9 kilometers in length.
yeah,
I don't know the exact. I don't. It's not spherical, but it's oblong. But we don't know the exact characteristics of it. It is showing a coma and was a coma and was showing a coma very early on. That's all I'll talk about in a moment. But it is. Uh, you get this. You get
I
this.
know. Yeah, and you get this,
And
and I think
it's
and I think as astronomers, you have to address it, if only to put it to bed, because yes, we can tell, but a lot of the evidence already points to be natural. In fact, some of the early observations suggest it could be billions of years older than our own solar system. So,
absolutely. Yeah.
it's quite a fascinating object just for that reason. So why you have to turn it into this alien spaceship, I don't know.
Yeah,
Um,
you think about it. This is a comet that's older than very likely older than the solar system from interstellar space, right? It's going through. We're going to be able to observe it. Not only that, we're going to be able to observe it with our spacecraft from the orbit of Mars. It's only going to be zero point 0.2 astronomical units from Mars. And the Mars Reconnaissance Orbiter has got a pretty good telescope on it. That story in itself is remarkable.
yeah.
It doesn't need to be it doesn't need to be Little Green Men or whatever you want. Doesn't need to be artificial. It doesn't need to be a spacecraft to be remarkable.
I know. And
And it's a great story in its own right.
I know, but it's like I said, I think these things need to be addressed if just to put to bed. Like, why are you worried about, extraterrestrials when just the fact that it could be so old and from another solar system is fascinating in and of itself,
It
right?
is. It is.
But the guy who put this up there, and I'm not even going to bring up names because I don't want to give them any kind of credit, is known for like throwing out some of these kind of crazy ideas. He had the same thing about Umeameya a couple of years back. So I do think he is a scientist in his own field, but it is not necessarily anything related to this kind of stuff directly. So
Uh,
yeah, it's kind of unfortunate. But even in science, we have crackpots.
yep, we do. We do.
We have, of course, I don't I just sort of remember the whole cold fusion thing from many years ago.
Yeah. Yeah. Well,
Like
there's all sorts of stories like that. Again, Arthur Clarke did us all a great service when he wrote Rendezvous with Rama. And if our listeners haven't read it, it is one of the greatest books ever written.
it's a
Um,
really good piece of sci-fi.
but
So
it's science fiction, folks. It
yeah,
really is. But speaking of the Atlas Comet and Vera Rubin, it turns out that the first instrument to detect this third recorded interstellar visitor was, in fact, the Vera Rubin telescope, not Gemini, which was what it was originally credited to. Um, it, After it was discovered by the Atlas program, which I believe used Gemini, uh, the team at Vera Rubin, they were in the middle of testing and commissioning the Vera C. Rubin Observatory, and they went back through their test images, and they did in fact see the comet there. It wasn't identified as such per se, but it was there in the data. Um, these were only test images, so none of the tools, the AI tools or the filters or the software, which the Vera Rubin team is testing and have at their disposal were deployed on it. So credit for the discovery will remain where it is now. But this shows the immense power of this instrument and how it will be used to foster other discoveries in the future. And it did show that there was a coma. It showed clearly the orbital path, and it did it, I think, about 10 days before the initial discovery. Um, it's interesting. Vera Rubin, it is believed, may well identify one interstellar comet or asteroid each year of its mission. Every time someone throws out a number like that, I always say to myself, no, we're underestimating it. We're going to find a lot. Used to be we didn't think there were any exoplanets. I think we're going to find there's a lot of, interstellar debris tripping through our solar system. And eventually, and this is a total aside, one of the proposed missions that the European Space Agency has is to put a number of smaller spacecraft at one of I think it's probably the L2 point, and just keep them there. And when we get one of these interstellar objects coming through the solar system that's interceptable, to be able to dispatch one of those spacecraft to intercept it. I think that's a great idea. The idea of basically having spacecraft up there, robots up there that can be assigned a mission on the fly, because things are changing all the time in astronomy and space science, and it would be nice to have that ability to respond quickly.
Yeah, I
So
mean,
we'll see. Yeah,
the sheer amount of data that Vera Rubin generates. I mean, that's what people have to understand about finding comets and asteroids. The sky is so big that this is why so many comet discoveries are named after amateur astronomers, because they just happen to be looking in the right direction at the right time to be the first one to see it, because the sky is so big. You're not using big telescopes like Hubble or James Webb or CFHD to comet hunt, because it's looking for a needle in a haystack. But Vera Rubin is a little different because of how it scans the sky. It may I mean, not just comets and asteroids uh, from outside our solar system, but even within our own solar system, it could find a lot more just because of the amount of the sky it actually scans, right?
yeah,
So it's like I said, comet hunting has been as much, well, until recent years when you've had more satellites up there that can take the pictures, it has been as much about amateur astronomers doing it because they're just scanning the sky night after night, looking for, these kinds of objects. Whereas the big telescopes, you always have a specific thing you're going to. You're not sort of scanning quite so randomly as you need to do to discover some of these objects. So.
yeah. And of course, we've also got the Nancy Romans Space Telescope coming online probably in, well, later this decade. I don't know the exact launch date. And it's going to be optimized for wide field viewing and infrared objects, which will also allow us to discover even more. There's a lot of debris up there. There really is. But I think, speaking of that, there's been theories about what that debris could have had, what effect that debris could have had on Earth, on an early Earth. So I'll turn this over to you, Mary, for
Yeah.
your discussions.
Yeah, so there's been sort of some recent publication on detection in of certain types of molecules in what we call the protoplanetary disk. Now, when a star forms, because of the rotational physics, it spins out a disk around the stellar equator, and this is the disk that planets will form out of, whether in our own solar. This is how we think it happened in our own solar system, and we can see it happening around other stars. So what they were doing is, looking at the specific chemicals in this disk And what was very interesting is they found some more complex organic molecules. In the article, they refer to them as COMs. Astronomers and other scientists are really bad. We love to short form everything, which can get really complicated because some short forms can have many different meanings in every different field. But so what they found were these larger complex molecules. Um, Basically, you're going to have to be a more quote unquote complex one. You have to have more than 5 atoms. At least one has to be a carbon, but some of them are even bigger than that. And it was originally thought that these sort of only formed a little bit later in the sort of planetary formation process. But what really interesting about the discovery in this protoplanetary disk is this is very, very early on in sort of the process. Okay. So the thought was as you go from the very early protostar that's relatively cold to that young star with the protoplanetary disk, it's a very active time in stellar development. And they thought the very shock waves and radiation and everything that occurs would have destroyed these molecules. And yet now they're looking at this disk and they're finding them already. Um, some of the chemicals they found are precursors to the amino acids lysine and alanine and glycine that are part of the human DNA makeup. There's some of the 20 odd amino acids that make up life on Earth. And this is, I mean, this protoplanetary disk was in Orion, um, only just over 1,300 light years away. So it's a relatively nearby star forming region. I mean, the Orion Nebula and Orion clouds were quite famous because these were some of the first ones where these protoplanetary disks were found when Hubble started first looking at them. Um, and and in some ways, this is great for the search for life because these are the bigger sort of complex molecules that we think, our kind of life originally developed out of. These are often the precursors to DNA and the things like the nucleotides and sugars and everything else that make us up. So it was fascinating to find them there, that they were starting to appear even earlier than we originally thought. And the fact that they're found in this protoplanetary disk means that these chemicals that make us up are probably incredibly common in the universe. It was already known that water and some simple carbon molecules and things like alcohol, ethanol, the one that we drink, had been found in these things in some of these clouds and stuff. But now finding these bigger, more complex ones is even more interesting. I mean, this is an early observation. They still need to do more follow-up, and they're hoping to do sort of some higher resolution observations to sort of make absolutely sure that they were correct on these initial detections. You do get that in astronomy sometimes. People will get an initial detection and they will write about it and they will publish it. And then they go back for sort of a second or third look. And sometimes it's there, and sometimes, the early data was just they were just a little too optimistic, which happens all the time. Um, but, sometimes it's better to publish it and then other people start looking so that you have more than one eye sort of on the problem. The other thing, of course, they're looking at is looking at other wavelengths because some molecules aren't so easily visible, aren't so easily viewed in the visible. So you need to go into infrared or the other direction into sort of UV to sort of see what's actually there. But even the possibility that you've got some of these chemicals occurring much earlier in the stellar sort of development process is sort of really promising for the potential for life to have arisen somewhere else other than our own solar system, which is a topic that fascinates us as human beings. It's in so much of our science fiction. It comes into, most people like in the Western world, if you ask them about extraterrestrial life, they're not going to ask like, what do you mean by extraterrestrial life? What the hell is that? They're going to say, well, they think it is or they think it's not. So it's something that we're sort of already there with. So it's kind of an interesting, it's another sort of tag on to sort of this whole search for life. So now would be some of the chemicals that they would have found on Titan earlier are being found in even many other places in the universe.
And
So,
it's interesting because Titan is thought of as a possible candidate for not life necessarily, but some of those precursor chemicals. This idea has been around for a while, and one of the big questions in evolutionary biology is not evolution per se, because that's a quite well understood and documented process. But how did it all start? So this idea is panspermia, which is basically that somehow Earth got seeded by natural processes, by complex molecules, which eventually evolved into life. There was another process, and we're getting near time, so I'll talk about it very quickly. But in the 1950s, there was the Urey Miller experiment, and I actually managed to recreate this experiment many years ago. But where you basically take the kind of combination of gases thought to populate Earth's early atmosphere and expose them to heat and lightning, energy, and do amino acids for them. And yeah, they do. Now, there's problems with both of these theories, but science is like that, right? You keep exploring until you come up with an idea and sort of whittle away the objections, and eventually you get there. But so this is a big story actually, because wherever we look, we do see this. We actually see organic compounds in comet tails, and we see that now in other stellar systems and so on. So life might be very robust, and it might just be a natural occurrence within the universe. We don't know. And that isn't a little green men thing. That's complex chemicals that can evolve and become self-replicating. So I see that we're getting near time. You've been listening to the York Universe, the Astronomy and Astrophysics podcast, written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Professor Mary Helen Armour and myself, Paul Mackin. This podcast and past episodes are available whenever podcasts are distributed. You can also connect with us on Instagram with the handle at YorkU Observatory, or on Facebook at Allan I Carswell Ob. Our website is yorku.ca/science/observatory. And of course, we did have the online public viewing this evening, and there were some great live images from the telescope. We're winding up with a couple of great archival images. Our website is yorku.ca/science/observatory. And there we have a lot of interesting content. And if you feel so inclined, it is a great place to make a Canadian tax-deductible donation to our student-operated, not-for-profit observatory. Thank you so much for tuning in this evening. We wish you clear skies and good night. Thanks for listening.